Good morning. In this video I'm going to cover questions 18 through 29 in the final exam review packet. 18 and 19 are asking you to rewrite each polynomial in standard form. So standard form needs to be written from greatest to least based solely on the exponents. Okay. So the coefficients don't matter, it's the exponents that matter. So if we look at number 18, the biggest exponent is the 3 and x to the third, so I'm going to write x to the third first. And then the next biggest exponent is this 2 and the 3x squared, so I'm going to write 3x squared next, followed by the x and 9x, but that's really negative 9x, so I'm going to write minus 9x and then minus 4. So number 18 is written in standard form, and if you notice it goes 3, 2, 1, 0 in terms of the exponents. So 19, we're going to look at the same thing. And the largest exponent in number 19 is the 4 in the 7x to the fourth power. So we're going to write 7x to the fourth power. It is positive. Okay, and then the 5x to the third power. So we're going to write plus 5x to the third power. And then plus 3x squared. And then plus 2. And again, notice it goes 4, 3, 2, and then in this case to 0. Everything is positive in number 19, so we're not going to have any subtraction signs. Okay, 20 through 23 are asking you to solve the problems using the laws of exponents. So 20 and 21 differ from 22 and 23, because 20 and 21 have an exponent outside the parentheses. So when you have an exponent outside the parentheses, that's when you would actually multiply the exponents. The first thing we're going to do here is take negative 3 to the fourth power, which is negative 3 times negative 3 times negative 3 times negative 3, which actually gives you positive 81. And then I'm going to multiply the exponents. So 2 times 4 is 8. So I'm going to write x to the 8th power. And then 3 times 4 here is 12, so it's going to be y to the 12th power. And that's the answer for 20. For 21, it's going to be very similar. First I take the number, the coefficient, which is 5, to the second power. It's going to be 5 squared, which is 5 times 5. So that gives me 25. And again, I'm going to multiply the exponents. 4 times 2 here is 8, so it'll be x to the 8th. And 3 times 2 is 6, so it's going to be y to the 6th. Okay? So that would be number 21. Number 22 and 23 are a little bit different. Okay, 22 and 23, you're going to be adding the exponents. I'm going to show you why. In these problems, you can write out each piece or each monomial separately and then just kind of count. So for example, in 22, make sure you see that, I'm going to write a 2, I'm going to write 1x, I'm going to write 3 y's, which stands for y to the third. And next I'm going to put a 3, I'm going to put 2 x's because it's x squared, and 1 y. Okay? And now all we need to do is multiply the coefficients. So that'd be 2 times 3 or 6. And we've got to count the number of x's. There are 1, 2, 3 x's, so that'd be x to the third. And then 1, 2, 3, 4 y's, so that'd be y to the fourth. And that is the answer for 22. Okay? 23 can be done in the same way, but now that you see how to do it, we're just going to do it real quick. We're going to say negative 4 times 2, which is negative 8. Now I'm going to add the exponents. X by itself is really x to the 1, so I have 1 plus 3, which gives me x to the fourth power. Then I have 5 and 4, which is 5 plus 4, and it's going to be y to the 9th power. So that's the answer for 23. Okay, 24 and 25 are similar in that you're following the laws of exponents, but we have a numerator and a denominator. So the trick here is to remember that you actually subtract. And again, I can show you why that works on number 24. So I'm going to do that. I'm going to write out each piece of the problem. So I'm going to write 36, but then I'm going to write 6 x's. I'm going to write 7 y's. Okay, so that's my numerator. The denominator, I'm going to write 4 and 3 x's, and then 5 y's. Do not have to do it this way. This is just an easy way to do it or to see why it works. So we're going to now cancel out what they have in common. I have x, x, and x, and then 2, 3, 4, 5. So what I have left on the top are 3 x's and 2 y's. 36 divided by 4 here is 9. X to the third y squared. And if you were to subtract the exponent, 6 minus 3 is 3, and 7 minus 5 is 2, and you have your answer. Okay? 25 is a little more complicated because you have the negative exponent. But the idea is the same. So you're going to say 15 divided by 3 is 5. 3 minus 2 is 1, or just x by itself. And then you have negative 2 minus 3, which is actually negative 5. So I can write it like this. But what happens is when you have a negative exponent, it switches places in the fraction. So this answer is actually going to look like this. And then the exponent becomes positive. Okay? Okay? For items 26 through 29, we're going to add or subtract as indicated. And the way I taught this was to kind of line it up. Or at least for adding, I taught it to line it up. So watch as I do 26. So I'm going to rewrite the first part, negative 3x squared plus 4x minus 7. Because it's a plus sign, I'm going to write a plus here, and I'm going to line up the corresponding terms. 2x squared underneath here, minus 7x underneath here, and plus 8 underneath here. And now I'm going to add them all together. Negative 3x squared plus 2x is negative 1x squared. You could just write negative x squared, that would be fine. Notice the exponent does not change at all. You have 4x plus negative 7x, which is going to give you minus 3x. You have negative 7 plus 8, which is going to give you plus 1. So this is the correct answer. You may also see it like this. I'm going to write that part, that possibility down as well. Either one would get your full credit. Now the subtraction is a little bit different. Okay? I want to kind of remind you how I did it. So what I did is I underlined the corresponding parts and I wrote them separately. So I said 5m squared. We have a minus sign here, so I'm always going to write a minus, and then minus m squared. And when you have minus minus like that, it actually becomes plus. So this actually becomes 6m squared. I'm going to do the same thing for the next piece. So here I have negative 6m. Again, we have a subtraction sign, and then 2m. Negative 6m minus 2m is negative 8m. And then I have 12 minus a negative 11, which again becomes plus. 12 plus 11 is actually 23. So our final answer here is 6m squared minus 8m plus 23. Okay? There's more than one way to do that problem. You could line it up like I did the first problem, or on number 26, but this is the way I taught it in class, so I wanted to cover it that way. Okay. So number 28, very similar, though you have to watch out for 28. Because notice that this part is 4x to the third, and this part is 5x squared, and you cannot combine those. So when we write it out, we have to be a little bit careful. In fact, I'm going to leave a space. Look for the 5x squared here. Okay, I kind of have a blank here because I have no x squared in that term, and just like I have no x to the third in this term. Okay, so when I add them up, I have this. I have 4x to the third plus 5x squared. We have negative 6x plus 9x, which gives me plus 3x. And we have 12 plus negative 15, which gives me negative 3. And that is the correct answer for 29. I'm sorry, that's for 28. For 29, I'm going to do similar to what I did on the other page. So I'm going to say t squared, which is the same thing as 1t squared, minus 3t squared, gives me negative 2t squared. I have negative 3t. Again, we have a minus in between. And then minus 4t. it actually becomes negative 3t plus 4t, which is 1t, or just t. It doesn't matter how you write it. And last we have negative 9 minus 17. Negative 9 minus 17 is going to be negative 26. So my answer is going to be like this. Negative 2t squared plus 1t minus 26. And just to be consistent, you could also write it as negative 2t squared plus just t minus 26. And again, either one will get you full credit.